Okay, I think we're safe to start. We want to be cognizant of everybody's time, and those who are late to arrive, well, they will get caught up. But first, let me thank all of you for joining. My name is Dan Greenberg. I'm the Director of Sales for BitYota, and I'm joined here today with Korey Lee, who is the CIO for SumAll. He will be sharing the SumAll data analytics story with us. Also with me is Palumi Damani. Palumi is BitYota's Vice President of Products, and she will be showing a live demonstration on how BitYota is being used by SumAll. So first, again, let me thank all of you for taking time out of your day today. We really appreciate it, and for joining us on this webinar to gain insights into frictionless analytics architecture. Now, for those of you who have not heard of BitYota before, BitYota is a data warehouse service, DWS, that is built to solve the problem of analytics over multi-source data, and to solve it on the cloud, and to solve it in a way where low latency analytics on data for fast changing web and mobile applications is a possibility. In this course of this presentation, Korey and Palumi will discuss with you what it means to have low latency analytics and what it really means to solve for data that's coming from multiple structures and multiple formats in the cloud. And they'll discuss all this in the specific context of the SumAll use case. So with that, and without any further ado, let me pass the ball over to Korey, and we can get started. Thank you very much. Korey, it's all yours.
Great, thanks, Daniel. So as Daniel mentioned, I'd like to provide just a little additional background on myself. This is a little bit about my my story. So I went to Berkeley, and then shortly after that started at PwC doing venture capital audit and tax, and then was at Google for a number of years before joining the startup world and the startup scene in New York. Been at Squarespace, AppNexus, as well as, and most recently, co-founded SumAll. And we've been in, or my background, I guess, is in the data and analytics and business intelligence space. And at SumAll, I oversee the infrastructure, kind of our data side, and as well as manage our internal KPIs and metrics. So the problem SumAll seeks to solve is really to understand and really connect data. So this is a chart of all the open source data that was available back in 2011. So as you can probably imagine, this has grown substantially since then. And as you can see, it's a very messy web of information. And so part of what we wanted to do is allow users to get back at this information, to allow SMBs to get back at this information. So whether you're generating, or whether you're using a laptop, a tablet, or a mobile device, companies, the apps that you're using are gathering information on your interactions. And all this really goes into the cloud, right? But what happens after that? So realistically, big companies are using this to their advantage. Target, for example, a few years back, actually found that one of their, or there was a use case, and it became headline news, that a teenage pregnancy was, they had sent a catalog or some kind of advertisement to this teenage mom's house, and her dad was furious. She's like, how dare you, say my daughter is pregnant? And the daughter had actually triggered a series of I guess algorithmic behaviors indicating that she was pregnant, whether she was looking at diapers online, or maybe she purchased a pregnancy test, home pregnancy test at Target, and she had to have that awkward conversation with her dad. So that's kind of lends to the point of big companies really using this data to their advantage, but it leaves kind of the smaller guys with nothing. So that's where we come in, and we really seek to make data easier. By kind of democratizing it, and I'll go into a little bit of our product suite. So we bring together about 30 different platforms, ranging from socials down to commerce and everything in between. So you have your Twitter, Facebook, Google+, and then you have the MailChimp and Blogger, WordPress, SEO Moz, eBay, and then down to your commerce, eBay, Amazon, Shopify, PayPal, MasterCard. And we've recently started adding Bitcoin exchanges as well, which has been an interesting new development in the commerce space. So as you can see, we really seek to make it easy. All you need to do to add your data is really just authenticate with your username and password, and maybe for some platforms an API key, but that's really it, and we do all the heavy lifting on the back end. So we process the data and feed it back to you in a very simple and easy to use interface. So this is one user that actually has given us permission to use their data. They're Pure Fixed Cycles, and they sell fixed gear bikes. So this is their Instagram, Google Plus, and YouTube feeds, and right away they can see a summary of their data, how they're doing week over week, and they can actually zoom into this data. So this is actually their charges, their sales data on Stripe, and see a breakdown of what their different forms of payment are. So looks like most people on their platform are transacting with Visa, and right away they can see what the relationship is between their data. So where we find it really powerful, and where most of our customers find the value, is that they can generate insights from this. They can start to see correlations and relationships within their data, and conclude that there's social is driving traffic to my site. Twitter is driving more traffic to my site than Instagram, so maybe I should invest a little more in that platform. And correspondingly, that traffic is actually converting into revenue for me. So it really allows them to get back at their data, and we're big believers in data transparency and data democracy. So the challenge that we face, and where BitYota comes in, is that we process about 30 million rows of data every single day. And if you can imagine, it's kind of hard to imagine what that looks like, but just to give you a visual image, if you were actually to print this out on 8.5 by 11 sheets of paper and stack it up, it would stack up to about the size of the Empire State Building and the Freedom Tower combined. So we're based in New York, so we use New York architectural references, but that just gives you a sense of the size of the data we're processing, and that's on a daily basis, and that's growing at a rate of 30% month over month, as we continue to add additional customers and additional platforms and integrations that we're hooking in for our customers to better bring all their data together. So that's frankly too much data. So we were trying to figure out how do we analyze this, how do we process this, how do we actually make use and get back at our own data. And this is just a little context on our tech stack. So we're on S3 on AWS. We store our data on MongoDB, and our front end is written largely in JavaScript, and for our visualization we use SVG, or scalar vector graphics. We recently moved from AWS over to ObjectRocket, and that was part of a conscious decision to kind of increase our performance output. So, and that really saved us a huge amount of time in terms of importing and getting our users their data in real time. As you can probably imagine, as a business, you want to see your data in real time, and we're actually able to show that to our users. As soon as they transact something on PayPal, it actually shows up in their SumAll account within a matter of seconds. And in order to provide the infrastructure and kind of real-time data access linking back to these APIs, we needed a better infrastructure. So for that kind of performance output, we turned to ObjectRocket. And looking at the various data tools out there for analytics, we assessed a number of different options. So starting with Excel, you have your very baseline kind of analytics tool. Of course, this is way too small for our scale. Excel accommodates about a million rows. And then beyond Excel, you go to Access, which is a basic SQL database. And then as you kind of grow and evolve, you go to MySQL, and then if you get really serious with MySQL, you go to Netezza. And these are all tools that we've used kind of in our past. And we assessed all of these as potential solutions to get back at our analytics. Initially, when we had started looking at our data, we were importing it out of Mongo, converting it, extracting it into a columnar database, and putting it into a MySQL DB on AWS. And that scaled for a few months, and it started to the import times got longer and longer, to the point where the imports were taking somewhere between 5 and 7 days, and we kind of gave up and realized that that's not a feasible solution. We have to find something else. We also looked at Cassandra and Hadoop, and there were a number of reasons why we didn't go ahead with these solutions. So Cassandra, at the time we started the company, which was about 3 years ago, was still a relatively immature and new product to the market, and we didn't have, we were concerned kind of with the speed of implementation. We wanted something that was familiar, and really we wanted, done is better than perfect sometimes, and we wanted to get product out the door. So in order to kind of optimize developer productivity and optimize on performance, we went with MongoDB. It was familiar to the skill set of our development team. It scales well for high growth, and it's also very productive off the bat. We were able to leverage a lot of the built-in features and whatnot. Redshift came along about a year and a half, maybe 2 years ago, and although it is a relatively inexpensive solution, it requires a lot of infrastructure development and build out from our end on the analytics front as well as from the data engineering side, and really we just don't have the bandwidth as an early stage startup to do that type of development. Hadoop is a great solution as well, depending on your application, but we found that it was hard to deploy with a lot of different pieces, especially with Zookeeper. Their batch processing system is great, but really real-time delivery is important, as I mentioned earlier, to our users. We want to give them their access to their data as fast as possible, and our desire to do everything in memory, all the processing, and really we are one of the leaders in the stream processing front. So pre-calculating, doing all the aggregations on the back end, and then really optimizing for read only. So again, Hadoop kind of has a lengthy build-out time and would require us to re-architect our data infrastructure. So we, again, chose Mongo for that reason. Netezza I've used at a couple other companies prior to this. At some point, it also doesn't scale well. It's largely based on SQL, and SQL has its limitations, and we actually hit the limitations of SQL and its ability to analyze and process data. So why BitYota? First, which actually isn't listed on here, but BitYota is really a cloud solution, and since we are a cloud company, we wanted something on the cloud that we could kind of use just straight out of the box. We didn't want to have to dedicate a lot of infrastructure, build out time, or developer resources to this particular project. Getting into the actual points on the slide, SQL over JSON is a technology, I believe proprietary to BitYota, that they developed, basically allowing a tool set for existing analysts who are familiar with SQL to run SQL-like queries on JSON-type data. So a lot of our data is Mongo is entirely stored in JSON format, so this becomes very easy, and it's a much easier for our analysts to learn SQL over JSON format rather than have to learn something entirely different like MapReduce or how to query data within the Mongo shell locally. So it's a much easier transition and a much less painful transition for our team, and it also allows us to update the data dynamically. As you may know, the structure of Mongo is really it's a NoSQL database, so it doesn't have it's a non-structured database, and by that it really allows our collections to change dynamically, and for us to have the flexibility without impacting the analytical ability of us to understand our data. Secondly, it's really fast. So something that we had encountered previously, which I touched on briefly earlier, is that our data imports were taking days, if not weeks, to run. And that became incredibly painful. Our data was no longer in real time. So BitYota actually, and Pulumi will probably go into this in more detail later, but actually tails our oplog and keeps our database fresh. We've, I think, resolved to have it at a kind of daily interval update, which is great for us. But when we started, they offered, it's like, do you want it to the minute? Do you want it to the hour? So it's really up to you and what your needs are. But having that speed and that real-time ability is really important to us. Likewise, the MapReduce, so not just fast in terms of importing, but also fast in terms of queryability. The MapReduce queries that we were running would crash or frequently run for hours, and the joins between collections were actually very inefficient, if not possible at all. But aggregations were also not particularly possible, or very limited. We had to scale it and then do multiple aggregations across multiple collections and then bring them all together and aggregate it again. Very painful. And BitYota allows you to do this very quickly. We can aggregate a billion-plus row collection within a matter of minutes, which is, to me, as a data guy, absolutely incredible. I kind of alluded to the real-time aspect of it, but having real-time data is definitely a huge value add, especially for us, and definitely should not be underestimated. And yeah, lastly, and probably the most important, is the awesome team at BitYota. So it's a very bright team. They've been constantly supportive and responsive of, to our needs and to our our growth as we've scaled over the past few months. Very proactive in optimizing and scaling with us over time. And even as we moved from AWS to ObjectRocket, they worked with ObjectRocket and Rackspace to build out an extractor such that we could extract our data from that platform instead of S3. So again, it's a custom solution which I'm sure they can leverage for a lot of things going forward as well. But definitely, felt the sense of a personal touch and a personal relationship with them, and that was definitely very important in deciding our partnership and continuing to work with BitYota going forward. So just to give you an idea of what the output of this data looks like, so this is a report that one of our analysts put together on the number of platforms that a user may add with us relative to their activity. So this is actually a joining of external third-party data from Mixpanel, which we use as a kind of third-party engagement tracking tool, and our internal data tracking our user activity or our number of platforms. So we're actually able to bring this data together in one place, which is incredible. Mixpanel data is also conveniently stored in JSON as well, so that makes it very easy, especially with BitYota's SQL over JSON tools. And as we continue to add events to Mixpanel, we need that type of flexibility to change the data architecture, but not necessarily lose the analytical power behind the data. So this is largely for internal use. So with that, I'll hand it back to Daniel to take it from here.
Excellent. Korey, thank you very much. And let me, with that and without further ado, let me pass the ball over to Palomi, and we're going to make her the presenter.
Thanks, Daniel. So, Korey, we think you're pretty awesome too. But, on a more serious note, when we started BitYota 2.5 years ago, this is exactly the problem we thought we wanted to solve. Today's fast-changing web and mobile companies, are looking for a data infrastructure that's flexible to change, that allows them to bring new data in quickly and generate insights on it without having to spend a lot of time sort of putting plumbing together. And when we met with SumAll and Korey, it was exactly that. Their data is growing at a tremendous rate. They're adding new sets of data, new feeds, pretty much on a daily basis. Interested in generating insights both for themselves and their external customers, and wanted a cloud service-oriented architecture. So it was sort of check, 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 along with some of the platform capabilities, which is we want to join across collections. We want to do ad hoc queries that could span several months or days. We want to generate aggregations. And you all want to do it using SQL because that's the language of choice that we've all grown up with in database 101 class, right? So I think the combination of kind of what we offered and just seeing users like Korey and SumAll just really resonate with it, sort of it warms the heart, right? And also this is why we formed BitYota, and this is the sort of the set of companies that we want to serve and grow with. So with that, what I want to do is walk through a demo where I will go through our web UI and pick up a data set that's a Mongo collection. I'll load it. I'll walk through some of the parameters you can use to load the data directly, and then query it. I'll show you how you can access JSON attributes, nested attributes, as well as join across collections. So those are the three things that I'll show, and then we can open up for questions. So I'm on the home page. It shows you kind of the 4 steps of launching a BitYota node. First is you launch a cluster. You can pick the size of the cluster and the number of nodes on it. So I'll just show you what we have here. There are several plans. We have the notion of a data node or a compute node, and this is one of the features of the BitYota system where you can essentially start slow, start with just a data node because that's where you're going to reside, all the data you want loaded in it, and then add compute as and when you need it, and as and when your computation needs grow. So if you're doing joins, if you're doing a lot of aggregations, you're going to need compute power. So you can add on to the cluster, run your queries, your analysis, your dashboard, your report, and shut down the compute node. Similarly, if you're going to do a lot of data scanning, you want multiple storage nodes, we have that flexibility. So you're not tied into kind of over-provisioning or having just one set of hardware that's kind of going to try to have to serve all your different needs. You have the ability to sort of mix and match, hit a price performance that you want, and sort of generate a size of a cluster as you need it. So I'm not going to go through sort of launching a cluster. We have one already. The next screen I'm going to go to is really how you would bring data in. So the first one is you identify a source. We support 2 clouds, so you can have Amazon or Rackspace. I'll use Amazon. You can do essentially an S3 bucket. You give it a name of your data source. You give us read-only access keys that you can generate so that we can go fetch the data from it. And this is pretty simple from a data source perspective. So that's a one-time setup that says my source of data is S3, and here's how you should access it. The next piece, I already have a bucket generated, which is the BitYota test bucket, just to show you kind of the data that we've added in there. The next piece I'm going to do is essentially bring in a data set. And this is a data set is essentially a source of a collection of files in the case of S3, which belong together. So this could be files generated from one collection in Mongo. So I can say my new Mongo collection, and my S3 bucket is this is a web app, sample web app that we've generated. The next field talks about dataset discovery. So we will sample a file within that dataset where we will go and discover the structure of your data. So we'll go read some subset of those and say, your JSON looks like this. It has these many attributes, and here's how it's going to look. And then when you're loading it, you can choose to load all elements or not. So we'll take a look at that. You can also choose to skip dataset discovery and provide your own schema if that's faster for you. And this works both on JSON as well as structured. So this is going to go off, go to that container, use my access key to read the file, fetch the first file, which is appdata.json, and then come back and say, here's what I think I found about your structure. And I'll take a couple minutes. And the idea is that this is a assisted schema discovery. So we'll read this. You'll have an option to sort of change it. You'll have the option to even take a subset of the JSON at this point and shred it into physical columns, or you can leave it as JSON. In the case of SumAll, they leave a lot of their data in JSON, so they get, because the attribute structure is changing a lot. And then there are certain stable things, for example, user ID, order detail, that they will take out into explicit columns because that's what they want to join and aggregate on a daily basis. So that's kind of the next piece. So while that's going on, here we go. So what we've done here is it's discovered the data set file name pattern is just star. You can also choose to give it my new star.json, any sort of Unix command there. It found a record delimiter. In this case, it's a line. And every new JSON document is a line. There's no field delimiter. We've also done some change discovery. So if you had, for example, if you were tailing the op log and you were dumping data into an S3 bucket every hour, we'd find that pattern and say, okay, it looks like your data is coming every 60 minutes. Do you want us to pick it up every 60 minutes? So this is just sort of data arrival schedule. The wait time is, in case it takes a while to write the file during that interval, we'll wait 30 minutes for the file writing to complete on S3. That's just a way for us to give you time to essentially fill out the data set. This is our JSON. You can choose to override the schema. In here, I'm going to just store it as JSON. The idea is you can also do, as I talked about, sort of breaking this out into individual columns, or I can even do computed columns. So I could do create an expression where it's E plus A is a computed column. That doesn't get stored in the database. That gets generated every time you run a query against this. So that's one way to do it. The next thing is actually loading the data. So this is my new Mongo column that I've just defined a data set on. And loading allows you a lot of flexibility into how you want to store the data on BitYota. So the idea is there's a number of tabs here. You can choose a new destination table. You can choose a cluster if you have multiple clusters. This is useful if you have, for example, an aggregations cluster or a raw data cluster, an ad hoc cluster, test cluster, and so on and so forth. We only have one, so we're going to leave it at that. This is our schema. You can see we've exploded just the first level of attributes. You can continue to go down. For example, L here is another JSON. You can continue to go down that nested list of columns as well. So I'm going to just leave it as JSON and not choose to extract any of these columns out, but that is also a possibility. You can override what data type it is, and you can kind of see what it's going to look like here. The table structure, we offer both row and column, so you can choose that. I'm going to do column generally faster. You can do random partitioning. You can do hash partitioning based on any key that you like. So this allows you to sort of, in each of your partitions, sort of segregate data so that it's evenly balanced. You don't have data skew across partitions, and it's easier to fetch. Or you can even do range partition. So you can say, my range partition is going to be date or some number, and you can give range values, and it'll create those partitions. So we allow several types of partitioning and sub-partitioning. By the way, you can also partition on JSON columns. So even if it's not fully taken out into individual columns, for performance, you can say, I want a virtual column partition on UID. You can do those kinds of things as well. I'm going to just leave it at random. The next thing, and this is just part of building sort of a simple data pipeline, is a preload and a postload step. So essentially, you can say, in SQL, let's do some count. I want to know how many records came in or how big the JSON is. You can just write a little SQL user-defined function. It'll check that and do something, then load the data, and then you can do a post-load step. So for example, if you were going to generate count, if you're going to generate min-max, any sort of mathematical function, this is a good place to put it. So we have a customer that's essentially generating their aggregations after every load. So they take the incremental data and they create another table which says, okay, on this incremental data, just do a count and a sum of these 5 columns. So that becomes, essentially it's a built-in data pipeline. And you don't have to do this outside of the system. It's on a schedule. If your loads are on a schedule, it's going to run on a schedule. And there's sort of fine-grained control. You can have multiple steps and so on. And then the load schedule. So we've talked about sort of a one-time load. This is only one file. I'll do a one-time load. But you can also set up a recurring load. And this is where the information we gathered about your data arrival schedule, we'll factor that in. So we'll say, start from which day and how often. If your data is not arriving, more than 60 minutes, then we won't load it earlier than that. We'll just leave it at that, right? So you can set up extracts every hour. You can choose to load every day. So you have that kind of flexibility. So I'm going to do a one-time load. This one-time load also gives you the ability to do historical load. So you can say, do a one-time load of last year's data because I want to analyze it from this date to this date. Or you can say, load whatever's available in the bucket. And we're going to do that. We're going to load whatever's available in the bucket. So it's going off. It's going to go off and create a new table. It's going to partition it the way we want it. And it's going to go pick up this data and load it on a one-time basis into that partition. And when it's done, it's now available for querying. So that's a very simple, one-time flow. But this can be set up on a schedule, and you can do this on an hourly or daily or weekly basis. So that's sort of the process of bringing your data in. So the one thing I didn't talk about was how you extracted that data. We have, for Mongo specific, we have in our Git repository, we have a Mongo extract tool that you can configure. It tails the oplog. You can do a one-time dump, or you can do an ongoing export at whatever frequency you want. And that's open source, so you can take a look at the source code, modify it, do whatever you need to. That's available in our Git. I'll publish the download link as soon as we're done with this. So the idea is that how you choose to bring the data is really up to you, and then we'll pick it up from a staging area like a cloud server. The next piece I want to do is I want to query this data. So I'm going to do a new query. I have data already loaded, so I'll just go with that. Let's describe the first set of data that I have. So this is just going to fetch me one document from data that I've loaded called Mongo C1. And so this is, everything stored in the same JSON column. It's essentially a list of music tracks. So that can get, it's got names, and it's got some sort of categorization associated with it, and so on. So it's a very simple general data set. It's got, who owns the data, and so on. So what I want to do first is, just be able to grab, in this case, I want to grab just the OIDs associated with this. So I can do from the JSON column. So what I've done here is I've essentially treated one of the attributes as a column. And if when you're familiar with if you're familiar with SQL, this is what you would do. You would just say select column name from table, and you can do something similar with the JSON attributes here. So for us here, ID is a column name. You can put any SQL workbench that you like against it, any SQL-based client. You can also call this, call this using our ODBC JDBC connector. So that's something that we provide. Korey uses it to query our data as well. Hang on, let me just see if I have the right query here. Sorry, that was a nested object, my mistake. So let me just try a nested object. I'm actually going ahead on the demo. So this is where I'm actually fetching the entire array of ID, and then I'm going to select essentially one OID which matches this particular OID. So this is getItems is a function that we've written that allows us to fetch an array, and then from the array you can enumerate individual elements of it as well. So that's the query we have here. And so it's going to fetch just that one that we're looking for, right? So N1 is my array that I've selected from, and I've fetched OID where I'm matching something to the value I'm looking for. You can choose, so it's just like any SQL expression. You can do where clauses, you can do joins, you can do distinct, count, min, max. All of those functions are available. And it's just treating it exactly like SQL. So that was a case where I was fetching an individual element inside an array, which was nested inside a JSON column. The next one I want to show is sort of a join across columns, and this is I have two different data sets that are essentially the same. So I have one called events, which is a streaming events table. So this is a fairly typical events. It's a mobile event, a streaming service. We've captured a bunch of things that the user does as individual attributes inside of JSON. I have a similar set from Flurry, so I'm just going to show you what that looks like, and then I'm going to join events with the Flurry data set using a common attribute, potentially UID. So my Flurry data set is called surprisingly, it's called Flurry data set. I'm just going to show you what that looks like as well. And so if I wanted to select, I can say, just the individual UIDs from this. I can do that. And this is, I'm fetching this particular attribute that's inside my JSON. This is a straight up upfront, not nested JSON attribute. So you can see, I have a bunch of UIDs over here, right? Now I'm going to join the two. I'm going to join Flurry and events and match where the UIDs are the same. So I've rewritten the query, and we'll just fetch that. So just like any typical structured SQL, I'm saying, select a column. In this case, I'm going to select the version of the app. And some parameter DV from two separate data sets. These could be two separate Mongo collections where the UID is the same. I'm going to limit it to 10, right? So very simple query joining across two separate collections. And you can see these are matched, right? So counts will work, distinct will work, min-max will work, all of those things will work. So that's in a nutshell, sort of take data, bring it in, set it up on a schedule to come into your data warehouse, and then query it very quickly as soon as it's loaded using sort of SQL over JSON as attributes, and do your sort of traditional discovery of data. So you can do things like, do I have data skew in my application? Are there, what are users doing in one versus the other? User profile match to their behavior on my website, which is something Korey would like to do going forward as well. So these are the kinds of things that you can do right away with us. And again, as I said, you can always take this and create physical columns out of it for even more performance. It's pretty zippy right now. This is about a few million rows of data from Flurry and from an event service. And then this is, if you wanted to do this programmatically, we'll set up a similar way. So you can call this from your Python or your Perl or your JavaScript or Ruby app and ping the database to fetch this data. And it's by user, so you can generate a unique API access key by user within your organization. That's the net of what I have. I'm going to open it up to questions if there's people on the line.
Excellent. Paulomi, thank you very much for that overview. It was fantastic. We do have a few questions that came in via the chat. And what I'm going to do is I'm going to unmute our phone lines as well so we can answer some of these. But the first couple of questions I have are for Korey. So Korey, the first question that we have here is, how easy was it to get the data from MongoDB?
Is that from MongoDB into BitYota, or just get the data out of MongoDB?
Just getting the data out of MongoDB in the first place.
It's not easy, to be quite honest, because it comes out in JSON format, and you either need to write we wrote Python scripts to convert that data into structured data so that we could import it to a SQL database. But as the data set gets larger, that becomes increasingly painful. Not so much the automated Python script part, but actually the process of importing it into something that you can actually use. So what we did in the interim before BitYota was we exported that data, converted it into a SQL-like column or structure, and then put it in a SQL database in AWS, and we created our own environment to do analytics, and that that was the process that I mentioned in the beginning. It took a few hours, and then as our data grew, it took a few days, and eventually became just not feasible for us to continue to do.
Excellent. So the next question we have, actually, I guess would play towards Paulomi then. Paulomi, is there anything that BitYota has done to help ease getting the data out of Mongo?
Yeah, so I mentioned the extract tool, and that's something that will go in. You can run it on a separate node. You connect to the database. It'll go in and read all the available shards. You can decide what shard and what collections and what shards you want to export, as well as whether you want to read from the primary or the secondary, what schedule you want to read at. The only thing you want to make sure is that your op log is not, since it's a capped collection, that it's not being overridden in the frequency between your pulls. So if you choose to do a daily pull, you got to make sure that you have enough history in your op log so you're not losing data. So that extract tool, as I said, is available, and I'll send out the Git location. You can take a look at it. We've actually given it to Object Rocket, and they're sort of facilitating pulling data out for SumAll on a schedule, and we just pick it up from there.
Fantastic. Thank you, Paulomi. And then we've got another question here as well. Why do we need to migrate the data from MongoDB to a SQL database? The question is, doesn't MongoDB provide a robust query language comparable to SQL engines, or does it not?
Yeah, so I'll answer the question in a couple of different ways. Mongo has its own query language. It also has an aggregation framework. All of those things are great for operational analytics. If you want to join your MongoDB data with something else, you're going to need to stage it into a different analytics system, right? So, for example, if you wanted to join Mixpanel or Flurry data with data you're collecting on your website on the server side, that's where, rather than sort of bringing it from Flurry into Mongo, you choose to do it on an analytics system. And the idea is that Mongo is great for operational analytics, operational intelligence, dashboarding, but when you want to start doing multiple sources, you want to do ad hoc querying, which are very complex. You might do very complex joins. You're better off with an analytics system that doesn't impact your operational workloads. That's where we come in. We've made it as simple for you to query JSON data as you have in using MongoDB, right? So we're preserving the flexibility you get from Mongo as an operational system into your analytics system. And the idea of putting SQL on top is, SQL is like English. It's, for data analysts and data scientists and programmers, it is the most widely known language, right? So there is no impedance to using your existing tools. There's no new language to learn, and all the constructs that are relevant. SQL has been around for, 40 years, that are well developed, that are well thought through, that are familiar. Windowing functions, range, OLAP operations, all of those are now available to you, even on the JSON side. So I think those are the questions are, if you want to do more detailed analytics, if you want to bring data together from multiple sources, and you want to have the efficiency of using tools and languages that you're familiar with, you should be investing in an analytics warehouse. We think you should be investing in BitYota.
Just to add to what Paulomi mentioned as well, just using MapReduce, which is one of the native tools that's built into Mongo, was great at a smaller scale, but as the data continues to grow, that becomes more and more difficult, and those queries tend to become much slower. It's also not particularly intuitive to the data analyst world, as she mentioned. And as you get into nested data structures, it also becomes very complicated, and some of the functionality, the aggregation functionality, and definitely the join functionality seems to break down in Mongo, whereas in SQL that's not the case. So that's definitely the strong suit of BitYota and how that it solves that problem and that pain point.
Excellent. Thank you, Palomi and Korey, for that one. I've got another question here that seems to be specifically addressed to Korey. Korey, how quickly are you able to do analytics on the data from Mongo and other sources?
So we're actually the data is updating on a real-time basis. So we refresh it daily. So we're able to query we could either automate the queries through Python scripts or via the BitYota interface, the web GUI directly, and generate daily or weekly reports at whatever frequency we desire. Alternatively, we can do ad hoc queries through our own SQL tools. We use SQL Workbench, Razor SQL, and a variety of other tools internally for our analysts to query the data. So those queries, I mean, depending on the nature of the query and the complexity of the query, the run times vary, but it could be anywhere from a few seconds to 10, 15 minutes for a larger kind of nested query with several subqueries. It just really depends on the complexity, but it is it's very performant and much more performant than previous.
Excellent, excellent. I've got one more question here before I open it up to an open discussion. The last question, I guess, is for Palomi. How are they able to improve the performance of their queries?
Yeah. So one of the nice things about SQL is it's a declarative language. So you don't have to physically know how your data is laid out, but you can do logical things with it. So you can say, I want to partition data in chunks of certain ranges. So you can say, I want to do by date. So if you were doing, show me everything since yesterday or show me everything since last week, date ranges become very important, right? So that's one. So we've talked about sort of laying out your data in very sort of logical chunks so that you're hitting the right chunk and fetching it very quickly. So partitioning is a great way of doing that. There are sort of row versus columnar stores. Columns are again, if you have a very 40, 50 attributes in JSON, but you're always going to be hitting a few of them at a time together, then columnar really helps because it allows you to just fetch partial pieces of your record very quickly. The third one is really the hardware you want to throw at the problem, right? So we've talked about being able to add nodes on demand of a certain type, and it's a heterogeneous cloud environment, so we offer different types of nodes that you can go against. And you can say, I'm compute heavy because I'm running aggregation, so I can bring more compute power on there. I'm scan heavy, so I can bring in more sort of storage heavy nodes. So those are sort of quite a few things that you can do. In the case of JSON, look, we live and die by our JSON performance. Our goal ultimately is to be, you should be indifferent to whether your data is in JSON or in structured. And that interactivity that a business analyst needs will come on JSON. So that's where we are. So we've done a ton of improvements in being able to fetch and query JSON directly. We've done sort of virtual partitioning on that as well. So there's a number of things under the hood that we've done to allow sort of true interactivity on top of JSON. And then there are ways, you can optimize how your query is written. You can do an explain plan. You can move things around. So there's, different ways of rewriting the same query. It's like grammar, right? There are 10 ways to write the same sentence, and SQL is no different.
Brilliant. Thank you, Palomi. Then I want to thank everybody for joining. We greatly appreciate it. As I stated in the beginning of the webinar today, we will be publishing a recording of this webinar within a few days. So we'll have that sent out to each and every one of you. If you do have follow-up questions that you would like to ask any of us, my email address is Daniel, D-A-N-I-E-L, BitYota.com, BITYOTA.com. Do not hesitate to send us questions, and we're happy to help you out in any way we can. Okay, so one last chance for anybody to ask any questions before we go our separate ways.
I wanted to say thank you. This has been very informative.
Excellent. Well, thank you very much. We greatly appreciate you taking the time. We look forward to catching up with each and every one of you after the call. And again, we'll have that webinar out to you very soon. Have a great rest of the week, everybody, and thank you.
Thank you, guys. Thank you, Korey.